Welcome to our probability class. Probability is wide. There are actually 7 versions of probability. So I'll break it down. Just look at 2 versions for today. So for probability, there are contingency tables that you can use to calculate probability. We also have trees, probability trees. We also have conditional probability. We also have binomial distribution. We have normal distribution. 6, 7, they can even be 10. Normal distribution. We have random variables. We also have what else? What probabilities do we have? Poisson. So I'll pick on a few of these ones here. Then we'll look at how the exam questions could come. Let me start with contingency tables. Now, the way I'll be teaching you today will be the easy tone. I'll look at the concepts and take you through questions, and you'll be shocked how easy these questions are. So to start with, probability has a few axioms or characteristics that you need to know. These ones will guide you. There are about 13. I'll only give you maybe 7 for now. So number 1, the probability you must understand is that probability for any event A happening is simply the number of events A out of the total sample space. So what that means is if we have 3 apples and 7 bananas, probability of picking an apple out of the total fruits of 10 is 3 out of 10, which is 0.3. So that is how we find the probability of A. Probability of A complement is simply 1 minus A itself. This simply means if the probability of A is 20%, to get to 100, we need a complement of 80%. So complement of A is 0.8. If our A is 40%, the complement of A will be 60%. Then we also have the union set. To unite is to add. So A union B is simply the probability of A plus the probability of B minus the intersection of A and B. Then probability of A given B. It's a pattern in Bayes' theorem. You bring down the B, then you intersect the 2 letters A intersection B. So suppose we have the opposite, B given A. Who can give us the same pattern that we use, but in a different way? How do we find that formula? Which data goes down? Okay, which one goes down? B given A will go down, correct?
A.
Then we intersect the 2 letters. So here, A will come down here. And on top, we're going to have what? The probability. We're going to intersect probability of A intersection B. You see this pattern, this one comes down, they intersect A intersection B. All together. Then we can also have the probability of A intersection B by multiplying probability of A, B given A, just cross multiplying this one here. B given A multiplied by A, you get the intersection of A, intersection B. So also to cross multiply this part here, A given B times B, it will give you the probability of what? A intersection B. So notice the pattern there, that if you have what is down as a multiplicand, it becomes an intersection. So here if there's B and here there's B, you get an intersection. If here there's A and here there's A, you still get an intersection. All right, so let's now look at some examples and apply them. So if you have the following, A, if you have the probability, you have A, B, X, and Y. We have 1, 7, 3, 9. So the first thing we total up. What total do we have here? Total for A is 8. Total for B is what? 12. And here, what do we have? 4. And here, what do we have? 16. And the grand total here is what? 20. So how do you find the probability of A? Remember from the formula, I said it's a number of A over the sample space. And our sample space is the total of all events. So that is our sample space here. To find the probability of A, we get the total for A, which is 8 over what? 12. So this will be 0.4. What is the probability of B therefore? The total for B here is 4 over 20 is 0.2. What is the probability for X? Wants to try?
Is
I
it
have a
20?
question. I
Mm-hmm.
have a question.
Yes, please.
On the one for probability of A, you used 12 on sample. How come for probability
Oh,
of B you're
sorry.
using 20?
No, it's supposed to be over the sample space. Correct. So it is the total for A, it's 8 over 20. Who wrote this 12 here? Miss. All right.
Hmm?
You're the one who wrote the 12 on my screen. Then the
Yeah.
probability of B is 4 over 20. All right. So let's go to probability of X.
12 over 20.
Correct. 12 over 20, which will give us what? 0.6. All right. Then probability of Y. 16 over 20, yeah? Is 0. What? 8. Is that clear? Then, if we want to find the probability of A intersection B, you go where they meet, you draw a plus A and B. Where are they meeting? At 1 over 20, which is 0. What? 0.5. How about probability of X intersection Y? Where do they meet X intersection Y? You draw a plus there. Where are they meeting?
9.
9 over 20, which is 0.45. So the union set is the most consistent formula. A union B. How do you find A union B? Probability of A plus probability of B minus intersection of what? A and B. So what's the probability of A? We found it was what? 0 point what? 4. Probability of B, we found it was 0 point what? 0.2. And the intersection was 0 point what? 0.5. So what do we get? We add and subtract 0.55, is it? Who wants to try the union set of A, X union Y? X union Y? Probability of what? X plus probability of what? Y minus the union set of X and what? Minus intersection set of X and Y. What's the probability of X?
0.6.
0.6. Y?
0.8.
Intersection?
0.45.
What's the final answer? 0.6 plus 0.8 minus 0.45, we get 0.95. Okay. Very easy, right? So what's the complement of A? If A is 40%, what is the complement of A? Zero point 0.6. How about the complement of B? If B is 0.2, what is the complement of B?
0.8.
0.8, correct. So I've taught everything you need to know about contingency tables. Now let's go to how the questions come if it's an exam. So you'll be given a scenario, question. For instance, a survey was conducted. We have 235 students. All right. So we have high, middle, and low, private and public sector. They've done the totals already for you. Messi, are we together so far? The information.
Yes, we are.
So now they're asking you what's the probability comes from a middle income family. What's the probability that the person comes from middle income family? It is what? Middle income is 100 over what?
235.
Good. Middle is 100 over 235. So this is correct. All right. So for those of you who have just joined, let me just give you an example. M, L, H, A, B, just to illustrate what we are explaining here. 2, 3, 4, 1, 8, two. Whenever you're given a contingency table, for instance, of these figures, first thing you total up. What we have here? 5. What we have here? 5. When we swap these numbers here, 2 and 1. So here I can put a 1 and a 2 there. So we just total up the figures there. So when you add this, we get a what? 4. Add here, what are we getting? 6. Add here, we're getting 10. And the A here, when you add up here, what are we getting? 4, 13. The add here, what are we getting? 7. The total here is what? 20. Right? Then they'll now ask you to calculate a number of things. Number 1, and the probability of A. So to find A, you just total A here is what? 13 out of 20, which is 0.665. What's the probability of B? You get the total for B, which is 7 out of the grand total, which is out of 20, which is 0.35. All right. So what is the probability of M? Oh, I can swap these two letters here. Sorry. This will be B and this is M. What's the probability of letter B? What's the probability of letter M? Sorry. M here. The total for M is what? 7 out of the grand total, 20. What's the probability of B? Who wants to try the probability of B? You get the total for B is what? 4 out of 20, 0.2. Are you following? But if they ask you what is the probability of A intersection B, you go where they meet, you draw a plus. A and B, they meet at what? At 1. So 1 over 20, 0.05. Who wants to try the probability of H intersection M? What's the probability of H intersection M? They meet at 2 out of 20, 0.1. So therefore, what is the probability of A intersection A and B? So according to the formula, we say it's the probability of A plus the probability of B minus intersection of A and B. So our A was what? 0.65. Our B was what? 0.2. And our intersection was what we calculated here, 0.05. So the final answer here will be 0.4. But if they ask you to find the probability of A given B and the probability of B given A, a word given can come as a word if or when. So you go where they meet, A and B, they meet at 1. But the total for B, what is the total for B? 4. So 1 over 4 is 0.25. Suppose they're asking probability of B given A. You go where they meet B and A, they meet at 1. But the total for A, the total is what? 13. You can calculate. All right. So 1 divided by 13, you get 0.08. So somebody tell me what is the probability of H given M? And what's the probability of M given L? Quickly. H given M? Personality? H given M?
Um, we're going to find, it's going to be probability of H intersection M divided by probability of M.
Yes, so probability of H intersection M over the probability of what? H
The
intersection M
probability M.
of M. So our H intersection M, we found it as what? 0.1.
Yeah.
And the probability of M, we found
Divided
it as what?
by 0.35.
135. Correct. Or the shortcut is where they meet H and M, just draw a plus. H and M, they meet where? At 2. But the total for the bottom letter here, the total for M. What is the total for M?
7.
7. 2 over 7. Is that clear? Now try M given L, the shortcut. M given L, who wants to try?
It's going to be 2 over 6. Right?
That's correct. So now let's look at this question. Okay. So now understanding what we're doing, we now apply it here. What's the probability that a student will come from a middle income? So you go to the middle, the total is 100 over 135. Then the word if a student comes from middle income. So you do this. If comes from the middle income, what is the probability that the student attends a private university? So private. So can someone tell me P given M? This is private, this is public. So private given M. Who wants to try? Where do they meet private and M? Private and mid, where do they meet? At 35. But the total for the bottom guy, the total for M, what's the total for middle?
100.
100. So 35 over 100, that's how we got this one here. All right. The word and means what? Intersection. So what's the probability that the student attends private university and comes from middle? So let's look for private intersection, what? Middle. So you go where they meet, private and middle, it's 235. But whenever we're doing intersection, we get the total of totals. But if there was given, we get the total of the one which is below here. So here, if the student came from middle, so if middle, what's the probability that came from private? So private given middle. So you go where they meet, private and middle 35. But the total for the bottom guy, the middle is 100. That's why I got there. But here, coming from private and middle. So end already, end means that using the total 2 35. But where are they meeting? Middle and private is still 35. But N is collective. The sample space is still 35. So this is where we have 35 over 235. Interesting, isn't it? Are
I have
we?
a question.
Yes.
Why are we using the final total, like the overall total? I understand it's in the formula to say you use sample or overall total, but then if you're going to be looking at just private and middle, why not use their totals instead?
So in statistics, like I said, there are words that you need to be very particular with, and they're just trying you to understand that this is what intersection. When you find the word or, you use the word union. These are key terms. So logically thinking, you may think the middle, you get the total, and private, you get the total. Yes, quite all right. That is what you would do if you're going to use the formula. Just to get the answer, but to simplify your thinking, just know that is the intersection. He's having both characteristics. From the middle and are coming from. So they are both characteristics. So these are the only ones with both characteristics. Because we're going to get this one here, the total, and you're going to get the private there. So you're also including the low, the middle, the high in that total, and also the private and the public in that total. So it will obliterate the essence of the question. So we're interested in the intersection. Is that clear?
Yes.
All right. So the student, what's the probability the student attends a public university given he comes from a low income? Who wants to try to give the narration there? The student attends a public university given he comes from a low income family. So where there is given, you put a slash. So given what? Low. What is the probability that the student is public? So public given low income. Where are we going? Where do they meet? Public and low, where do they meet?
On 70.
70, correct. But the total for what now in this case, public and low? The total for what? For everything or the total for law?
For law,
Good. And our law is what? The total for law is
90.
90. So 90. So that's how this one's supposed to be done. So what's the probability that the student attends a public university and comes from a low income family? Who wants to give us a narration? Public university and comes from a low income. So what are we doing? Probability of what?
Public intersection, low income.
Good. Public intersection of law. So what are we going to do at this point? Where they are meeting public and law, divided by what? What total are we going to get here?
$235.
The total of everything. All right, so where they're meeting and the total for everything. So public and law, where they're meeting? $70. Public and law, they're meeting at 70. Is it? Then the total of everything here is 235. This is where it's coming from. Now, what's the probability that a student attends a private university? What are we looking for? What denotations are we looking for? And the probability of what? Private. That's all. So what was the total for private over the sum total? So private is what? 79 over what? The sum total of everything, which is what? 35. So this is a very complex but easy way of finding probability. Have we understood it?
Yeah.
I joined late, but
All right. Now there are other few assumptions that you need to know. Sometimes we ask some conditions. So for us to know that events A and B are mutually exclusive, we need to ensure that the intersection of A intersection B has equal to 0. This is only if and only if events are mutually exclusive. Mutually exclusive means to have nothing in common, to have a 0 intersection. So if A intersection B is equal to 0, it means they are mutually exclusive. If A given B is equal to probability of A, you maintain the top guy. Or if B given A, you maintain the top guy is equal to probability of B. You see, they are maintaining the top guy. It means these ones are what? Independent. So independence only occurs when A given B is equal to A, or B given A is equal to A, or whatever A given whatever is still A. B, whatever is down there, whether it's R or Z, the solution must be equal to the top guy. So in this case, what we have here, we can say that A and B are not mutually exclusive because our answer is 0.005 instead of 0, so they're not mutually exclusive. Are they independent? Wait a minute. For us to know whether they're independent, what is the condition for independent? A given B must be equal to what? A. Or B given A must be equal to what? B. So the first thing is you need to find what those parameters are. So in this case, what was our A given B? You go where there is A and B, where do they meet? At 1. Over the total for the burst, which is the total for B is what? 4. Is 0.25. Then it must be equal to A. What is the probability of A? That's 8 over the grand total over 20, which is 0.4. So A given B, for them to be mutually exclusive, must be equal to what? A. So what was our A given B? 0.25. And what is our A? 0.4. Are they the same? No. So we can conclude that these ones are not what? They're not independent. So this is for independence. And this is for what? Mutually exclusive. It means they are mutually exclusive is equal to 0. So there was a question that they asked here to say, are the events public, university, and coming from low income independent? Question is, what is the probability of what is the condition for independence? It must be public given low must be equal to what? Public. So let's find the probability of public. What is the probability of public? It is 156 over 235. Then also public given low. What is the probability? Public given low income. So we will go at a meeting public and low. It's 70 but the total for low was 90. So you need to evaluate these answers, they need to be the same. So if this answer gives you the same answer there, then you can say they're independent. But in this case, when we evaluated, there were different answers we're getting. So meaning the answer is that they're not independent. So with that being said, I'll ask if there are any questions so far. Are there any questions?
What did you say on these two? Are they giving us the same?
No, they're not giving us the same answer.
So they are not independent,
They're not
or they are
independent.
independent rather.
They're not independent. They're only independent only if the answers we're getting are the same. Okay. So, any other questions? And look at another last example, then we end there. In the
Collins,
yes, sir.
yeah, I just want to understand. I think that the question that she asked, I don't know if it's in Cosinati or the other lady.
Mhm.
How do you know is to use the total probability for everything, and when do you know you have to use the total for?
So when you're told probability of A intersection B, it is where they meet divided by what? Total of everything. Of everything. If you're told
Okay.
probability of what? A given B. It's where they meet, but the total for what? Total for B. If you're told B given what? A. It's where they meet, but the total for what? Total A. I hope this is helping. If they say A and B, it means it's A what? Intersection B. If they say A or B, it is simply A union B. Okay? If they say probability dash 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 if A, it means whatever they're talking about, if it's B but given A. If they start saying if A dash dash, it means whatever you talked about, but A must be down. If they say probability assuming A dash dash dash, it means whatever you're talking about, whether it's B or any other, A must be down. So this must be understood clearly. It will help you and guide you. So in that manner, you know whether it's an intersection, it is the total of everything. But if it's a conditional probability, it's obviously going to require you to identify which probability will go down. Okay. Are we together?
Yes.
All right. So, any other questions before I do another example? Any other questions? I want you to like this topic. Probability is very difficult. If you don't get the concepts very well. So let's be objective, all of us, as we look at another example of the common questions that usually come. Okay. So there's a revision kit that I once sent on the group. Let's review it, that revision kit. Question on conditional contingency tables. Here we are told that the data below shows a number of cars that are used in local dealership. New use. What did I say is the first thing you need to do? So we have new, use, SUV, and so help me. So here we have what? New, use, and we have SUV, sedan. We have numbers like 24, 15, 9, 12. 24, 15, 9, 12. Then we had the following questions to answer. So, why? So each one of you should answer a question before you go. So what's the first thing we do when you're given a question like this?
We total them.
We total them. Okay, so what total are you finding? Yeah,
New. The total for new
three here,
is
new,
39.
okay, 39. Yeah, 21. What's the total of totals? 6. All right. So who wants to try part 1? Determine the probability that a randomly selected car is new. What are they asking for?
The probability of the car being new.
Okay.
So it's going to be 39 over 60.
9 over 6, correct? Hmm. 9 divided by 60. So we have 0 point. Yeah. Next. Somebody else, probability that the random selected car is a sedan. What are they looking for?
It would be 33 over 60. Probability of sedan, sorry.
Probability of sedan to start with, yes. So which is what?
33 over 60.
Correct. So what do we get? 0.55. Then next, determine that the probability of a selected car is a new sedan. There's an invisible and there. What are they looking for? New sedan. So and becomes what? Intersection, yes. What becomes the answer there? U intersection sedan quickly. What's the answer?
Should be 24 over 39.
24 over. Over what?
39 or 60.
Somebody help him. 24 over what?
60.
60, yes. Intersection is over everything.
Okay, yeah.
So what do we get? 0.4. Then lastly, what are they asking for? Determine the probability that the random selected car is either used or SUV. What are they asking for?
Union.
What is the O for? What does the O come to be? Anyone? O
Is it union?
yes, union. O stands for union. So O union SUV. So how do you break this one down? A bit of U plus a bit of what? SUV minus a bit of what? U intersection SUV. So what's the probability of U used? And 1 over 60 plus SUV and 7 over 60 minus the intersection. Where do they meet used and SUV? 12 over 60. And you get your answer there. All right. So this is
Sorry,
this.
Colin.
Uh-huh.
Is that 24 or 25? The first one.
Used, the total for used was what? 21 over 60.
21, okay.
Then SUV 27 over 60. Then why they meet you is what 12 over what? 60. So you add 21 plus 27 minus 12. Which is 36 over what? 6. So you divide that by 6, you get 0.6. So I'll send you homework based on what we have covered. Thank you so much for your time.